You can see this lecture is about circles. That is, given the equation of a circle, graph the circle, and to graph the circle, we need to know the center and the radius, or given information, determine the equation of a circle. So we're talking about circles in general. But to start, we need to remember or know the distance formula. The distance formula is a way of calculating the distance between 2 points in the plane. Now, to do that, we first need to, I want to make a point here of calculating distances between x values and distances between y values. Okay, so let's just kind of determine here. We've got, deal with this. Here's 1, 2, 3, 4. And let's say here's 1, 2, 3, 4. And over here, let's say -1 and -2. Okay. Now, suppose we look at the distances between these 2 points. And to do that, obviously, we know, and we'll call that distance D, but we know in this case that distance, we can just count it off. Let's see, 1, 2, 3, 4. There's 1 unit to here, 2 units to here, 3 units to here, so the distance is 3. Now, what I'd like you to notice, though, that we could also calculate this distance by looking at the largest x value, which is 4, and subtracting the smallest x value, which is 1. 4 minus 1 is 3, and so that's the distance between those 2 points when we're looking at the largest and smallest x values. And that even works if both x values are positive, if both x values are negative, or one x value is negative and one x value is positive. For instance, looks at the distance between this point and, say, this point. Okay? And in this case, we can calculate by simply counting. Let's see, 1 unit, 2 units, 3 units, 4 units, 5 units. We get a distance of 5 just by counting. But if we use this same process that we used before, the largest x value is this 3, isn't it? And subtract the smallest x value, which is this -2. When we say 3 subtract -2, we get a 5. So the distance between x values is the largest x value minus the smallest x value. Okay, I've kind of run out of space there. Well, once in a while, we don't know which one is largest and which one is smallest. So another way to do this is to say, okay, the distance between x values is simply the absolute value of one of the x values subtract the other x value. Okay? And it really doesn't matter, and I've called those subscript 2 and subscript 1, but all that matters is it's we need to ensure that we get a positive result. So for instance, if we look at this position and this position, well, let's do it this way, okay? We can see the distance here. Let's come down here. We can read that the distance is what, 4 units? Because we can just count it off. But we could also calculate the distance by taking the largest x value minus the smallest x value, or we could use absolute value idea and say, okay, take one of the x values. Well, one of the x values is -1, and subtract the other x value, and the x value is 3. Now, if we take the absolute value of that difference, you can see here Negative 1 subtract 3 is a negative 4, and since we have absolute value, we're going to get a result of 4. So the distance between x values is just the absolute value of the difference of the two x values. And in a very similar fashion, the distance between y values, I'm not going to go through the idea, but you can imagine it and you can practice it. The distance between y values is largest y minus, I'm getting really sloppy here, the smallest y. Or we could simply say it's the absolute value of the difference between the two y values, and that will always give us the distance between the y values. Well, this idea is important when we're deciding how this distance formula works. So let's on the next page, actually calculate the distance between a couple of points in the xy plane. They're not going to be horizontal or vertical. Well, in this example, or this problem, if you will, this is to help us decide how we're going to come up with a formula for the distance between 2 points. We'll look at a specific example first. So we're to calculate the distance between the points 1, 2 and 4, 6. And if we look at 1, 2, that's a point that's right here, and 4, 6 is a point that's right here. So we want to know the distance between those 2 points, which is equivalent to calculating the length of this line segment. Okay? And so let's call the length of that line segment d for the distance between those 2 points. Now this is really very clever. What we're going to do is from this point here, we're going to drop a vertical that's at the same horizontal level as the point we have here. And so we're going to make a horizontal there. And so what we've created, of course, is a right triangle. Okay, that's what we've done here. Now, in this right triangle, D is the hypotenuse. And we know from the Pythagorean theorem that a squared plus b squared is equal to c squared when we're dealing with a right triangle, where a and b represent the length of the legs and c represents the length of the hypotenuse. So in this case, we're calling the hypotenuse d rather than c. And so what we have is that d squared is equal to a squared plus b squared. Now we might call this side a and this side b under these circumstances, okay? So now d, of course, is a length. It's the distance, the length of the hypotenuse, the distance between those points. So d squared can't be so d can't be negative. That is, d must be positive. So d is the square root of a squared plus b squared, not plus or minus the square root. So to calculate the distance, all we need to do is figure out a and b, okay? Well, we can look up above, and we can calculate that the length of a is what, 1, 2, 3 units? We can calculate that the length of a is 3 units. And we can look up above and calculate that the length of b, let's see, 1, 2, 3, 4 units. So b is 4, so we have a 4 squared in that position. So d is the square root of 9 plus 16, and of course 9 plus 16 is 25, so d is the square root of 25, or the distance between those 2 points is 5. Now, the way we, on the previous page, if we look at a, that's really the distance between 2 x values, isn't it? See, a is really the distance between the x value 1 and the x value 4, so we could have calculated as 4 minus 1. Okay, and that would have given us a 3. Now notice up above, the 4 is the x value of this point, and the 1 is the x value of this point. And of course that makes sense as we look at the diagram, okay? Because the point that's right here has the same x value of the second point, that's 4, and the point here has the x value of the first point because it is the first point. So we actually could have calculated A by just saying the absolute value of one x value subtract another x value, which would be 3. But we're going to ultimately square A, and when we square A, then we're always going to get a positive. So the absolute value ends up not making that much difference, okay? And so we would have had 4 minus 1, or 3 squared, which is 9. I'm doing this in a way because I want it to be obvious what we're going to do. We're going to generalize here in a moment. Now, B, we looked and counted to see the distance of B, but B could have been calculated by taking the largest y value, which is 6, and, between these two positions, and the smallest y value, which is 2. 6 minus 2 is 4, and that's what we counted. But we could have said B is simply the absolute value of 6 minus 2, which would have still been 4. Now, B squared, we don't really need to deal with absolute value because B squared is always going to end up positive, and so we could have said B squared comes from 6 minus 2 and squaring. Now, the reason I'm going through this is look at the 6, that's this value, and the 2, that's this value. So, more generally, look at A. More generally, okay? A is one x value subtract the other x value. That's what A was. It was this x value subtract this x value. So A is one x value subtract another x value. And look at B. B is nothing more than the difference of the two y values that we saw here. So whatever those y values are, B is one y value subtract the other y value. Now, here's what I mean. Okay, more generally, find the distance between the points, and in this case, more generally, the points, the first point or A point has an x value of x subscript 1 and a y value of y subscript 1. And the second point has an x value of x subscript 2 and a y value of y subscript 2. Okay, so just given a couple of points generally. Well, then the distance between those 2 points, and I'm actually going to call it the distance formula. Well, how did we calculate a while ago? It was a square root, wasn't it? See, it's a square root of a squared plus b squared, where a was the difference between the two x values. And so if we have a, the distance between the two x values, well, one x value is x subscript 2, and the other x value is x subscript 1. Okay? And of course that a is squared. This is nothing more than the a value. Plus the b squared, but b is nothing more than the difference between the distance between the y values, which is the difference between the y values. One y value, a y value here and a y value here, that's b, and b has to be squared. So this is the distance formula, and this is very important in things that we do next and in the future. So as long as we know 2 points that are in the plane, we can use this formula to calculate the distance. And we don't have to know which is the first point, which is the second point. All we have to know is 2 points, and we just need the difference between the x value squared and the difference between the y value squared, add those together, and then take the square root. Now, in our example just a moment ago, we got a whole number for the distance, okay? up above, we got a whole number. Usually we don't have nice whole numbers as the distance between 2 points. So let's look at an example on the next page using the distance formula. Writing, I apologize for that. Here we're to calculate the distance between the points 3, -5 and 6, 1. And we don't really need a diagram to make this determination. But, you know, we could look at a diagram, but we don't need it. I want to make that clear. Let's see, 3, -5. Let's see here. I'm just kind of sketching real quickly. 3, -5 might be something like this. Okay, it might be a point like here. And 6, 1 might be a point like right here. And so we're wanting to calculate the distance between those 2 points. Okay, that's the issue. But to do it, we use the distance formula. Now, you're expected to know this formula. Okay, and the distance formula says, okay, to calculate the distance between 2 points, we calculate a square root. And under the square root is the difference between the x values of the 2 points, the quantity squared, plus the difference between the 2 y values, the quantity squared. Now, I might add here, before I go any further, it depends on the book that you read or the help that you get. Sometimes those subscripts are interchanged. It might say x sub 1 minus x sub 2. But remember, it doesn't matter which one we put first. We normally are in the same order, but which one we put first, because the difference between the x values and the absolute value of those always gives us the distance between the x values, and that's all we really have there. When we square it, we end up not needing the absolute value. So all we have to do is decide which x we're going to put first, and our choices. Here's an x value, and here's an x value. And it really doesn't matter which one we choose to be x subscript 2. I'm just going to say the 6 is x subscript 2, and so the x subscript 1 will be the 3. So we have x sub 2 minus x sub 1 squared. Now, since I called x subscript 2 coming from this point, then I'm going to say this is y subscript 2. Okay, so I have a y, subtract the other y. Now remember, the formula has the subtraction. Okay, and so this is the subtraction in the formula. But what I'm subtracting is a negative y value, so it would end up looking that way. Now, as I begin to do my calculations, of course, 6 minus 3 is just 3. So here I have a 3 squared, and 1 minus -5 is the same as 1 plus 5, so here I have a 6 squared. And of course, as I calculate, that is what? 9 plus 36, which of course is, the square root of 45. Now, we might stop and think, can we actually simplify the square root of 45? And I believe we can, because 45 can be written as 9 times 5, can't it? And so we can take the square root of 9 and get 3, but we can't resolve the square root of 5. And so we would generally leave this as our answer rather than getting out our calculator and approximating it into a decimal. It's normal that we leave it as exact value. That's normal. Unless you're told to do otherwise, leave it in this form. Well, this should set us up to be prepared now to talk about circles, because we need to use the distance formula when we discuss circles. So we'll begin that discussion on the next page. Well, here we're being asked to graph, graph the circle of head, whose center is at the point 4, 2 and has a radius of 3. And we're going to do it by hand. In fact, at this point, it's really easier to do this by hand than it would be to try to even think about a calculator. So we've got to find the center, 4, 2, and that looks like that's right here is the center. Now we recognize the center is not part of the circle. That's just where the circle radiates from, okay? Now, here's what we know, is that if we move, the radius is 3, so if we move 3 units in any direction from that center, then we're on the circle. And so we're going to move in a way that's easy for us to determine. I'm going to move 3 units vertically. So if I move 3 units vertically, 1, 2, 3, that puts me at this position. So that is a point that's on the circle. Now if I move 3 units downward from the circle, vertically downward, 1, 2, 3, that puts me at this position. And that's also on the circle. Okay, now if I move to the left 3 units from the center, 1, 2, 3, that puts me at this position. And if I move to the right, 1, 2, 3, that puts me at this position. And so I have 4 points that are on a circle. Now, please don't laugh at my circle when I draw it, okay? But it goes kind of like this, doesn't it? And then it comes down here and hits this point, and then it comes up here and hits this point, and then it connects right there. So that's not bad for freehand. There's the circle that's being described above. Now, let's next find the equation of the circle. Of the circle with center, okay, this is the same circle, I'm just restating it. Center is at 4, 2, and radius 3. Okay, let's find the equation of that circle. And that sounds kind of daunting, but it's really not too bad. What is an equation? Well, an equation is something that involves x and y, and the relationship between x and y calculates points that are on the circle. So let's just talk about a general point that is on the circle. We'll call that position x, y. Okay? Now, of course, the center here, the center is 4, 3. Let's keep that in mind. Now, if I take any point that's on the circle, and I draw the line segment between the center and that point, well, that distance is called the radius, isn't it? And in this case, we know that the radius is actually 3 units. But that's also the distance between the center, okay? So r, which is equal to 3, is the distance between the center, which is 4, 3, and any point x comma y that is on the circle. So, but how do we calculate the distance between 2 points? Well, remember the distance formula is d is equal to the square of the difference between the x values plus the square of the difference between the y values. That's what the distance formula says to do. Now, in this case, the distance is actually r, or 3, okay? And in this case, we're looking at the point x comma y and the center 4 comma 3. So we could say that we'll take the x value that's of the general point, which is calling that x, and we can subtract the x value of the center, which is 4. And we got to square that. And on the other hand, the point that's on the circle has a y value that we're calling y, and the point that's the center, we're finding the distance between these 2 points, has a y value of 3. And so we've got to square that. Now, what we would like to do is to not have a square root. So we're going to square both sides. And when we square the left side, of course, we get 3 squared, which we know is 9. And when we square the right side, we get what's under the radical, called the radicand. Okay, radicand. Now, if I turn this around, then this becomes x minus 4, the quantity squared, plus y minus 3, the quantity squared, is equal. I goofed, didn't I? The center is 4 comma 2. My bad. I'm just noticing that. So this is actually a 2 square, a 2 here. The radius is 2, isn't it? No, the radius is 3. My bad. I've really screwed this up. I was right here. The distance is the radius, and so we have a 3 squared here. But the center is 4 comma 2, not 4 comma 3. So we're subtracting a 2, a y subtract a 2, a y subtract a 2, a y subtract a 2. I apologize for that. Is equal to 3 squared. Now we would probably write this as x minus 4, the quantity squared, plus y minus 2, the quantity squared, is equal to 9. That's probably the way we would write it. But what I want you to notice is this 4 is the x value of the center, this 2 is the y value of the center, and this 3 is the radius. So if we could have done this more generally, okay, the equation of a circle with center, let's say just generally, h comma k, we'll call that the center. And radius we'll just call some general number r, okay? Then if we follow this same pattern, look what we would have. We would have x minus, instead of 4, which was the specific x value of the specific center above, here our center has an x value of h. So it would be x minus h rather than x minus 4, the quantity squared. Plus, we would have y minus, instead of 2, which was the y value of the center above, here the y value of the center is k. So we'd have y minus k, the quantity squared, is equal to, rather than 3 squared, remember 3 was the radius, here the radius is r, so it's equal to r squared. That's an r. And this is the, sometimes this is called the standard form of the equation of a circle. And sometimes it's called by another name. Sometimes it's called the center radius form. Okay. Sometimes it's called the center radius form, because of course we're using the center and we're using the radius. But nonetheless, if we know the center of a circle and we know the radius of a circle, we can just plug those values into this formula and we actually have the equation of the circle. Wow, that was pretty easy, really, wasn't it? Well, let's practice this on a couple of examples. Okay, I've rewritten just to make sure that you understand that this is something that we need to know. The standard form of the equation of a circle that has a center of h comma k and a radius of r is given by the formula, the quantity x minus h squared plus the quantity y minus k squared is equal to r squared. And you notice in the x minus h, that's take x and subtract the x value of the center, and the y minus k, that's take y and subtract the y value of the center, and of course r is the radius. So our first problem is to write the equation of the circle with radius 3 and center 1 comma negative 2. And so we just have to recognize that the radius 3 is represented by r above. And the center above has an x value of h, so this 1 is the h, and it has a y value of k, so this negative 2 is the k value. And so we just, although it's not a mathematical terminology, we just plug away. That is, for the equation, we say x minus h, but this time h is 1. So x minus 1, and of course we have to square that. And we add to that y minus k. And remember, the minus is in the formula. And this time, though, our k is a negative number. So it's going to be y minus the negative number, negative 2. Don't forget we square that. And that's going to be equal to the radius, which is 3, squared. And then we would just clean up a little bit. We would rewrite this as x minus 1 the quantity squared, but here with the y's, y subtract negative 2 is the same as y plus 2. The quantity squared is equal to 9. That's the way we would end up writing the equation. Okay? So that's the equation of the circle in question. So notice, if one of the coordinates of the center is negative, when we're finished, we'll have a plus in the parentheses that are being squared rather than a minus. I'm sure you noticed that. Okay, let's look at another one. Here, let's say that the same kind of question, write the equation of the circle, but here the radius, let's say, is 2, and the center, let's say 0, 5. Now we can graph these, but right now we're just worried about writing the equation. So now, of course, this time the r value is 2, and since this is the center, the h value is 0, and the k value is, of course, 5. So we just start right away. X subtract the x value of the center. Well, the x value of the center is 0, isn't it? Square that. Plus y subtract the y value of the center. And the y value of the center is 5. So we square that. And then that's equal to the radius squared. Since the radius is 2, we have a 2 squared. Now, x, let's go back and clean this up. X subtract 0 is the same as x. And so when we square x subtract 0, we really just have an x squared plus a y minus 5 squared is equal to 4. So this is the equation of the circle in question here. Let's do one more, and then we'll kind of switch gears. Write the equation of the circle that has a radius of 1 and a center that is at the origin. Okay? Well, again, we can go back through here pretty quickly. When we're coming up with the equation of the circle, we take x, subtract the x value of the center, which is 0, and we square that, and then add to a y subtract the y value of the center, and the y value of the center, of course, is 0, and square that quantity, and then that's equal to the radius, which is 1, squared. Well, x minus 0 is just x, so here we have an x squared. Y minus 0 is just y, so here we have a plus y squared. And of course, 1 squared is just 1. And that's the equation of the circle. And by the way, this is called the unit circle. The unit circle is the circle that is centered at the origin and has a radius of 1. So this would be where 1 is, this would be where 1 is, this is. You can see here we're asked to find the center, the radius, and the intercepts of the circles whose equations are given by the following equations. And the first one, of course, is x minus 3 the quantity squared plus y minus 1 the quantity squared is equal to 16. So let's just rewrite that equation right here. Okay, now to come up with the center and the radius, we're comparing it to the general form. Okay, so the general form here. This is what I say the standard form is what I should be saying, the standard form of the equation. And of course here what we know is that h comma k is the center, and here we know also that the r is the radius. And so we're just simply comparing. And, you know, when we compare and look above, oh, well, the h must be 3 and the k must be 1. So we can quickly say that the center is h comma k, or 3 comma 1. And, of course, in our case, on the right side, we have a 16, and that represents the radius squared, r squared. And so r itself, since r squared is 16, then r must be the square root of 16, which of course is just 4. So the radius is 4 here. Now, we could come up with a quick sketch of this graph, and that's not really what's so important to me, but I do want to kind of point it out here. 3 comma 1, well, let's see. Let's just kind of sketch this in. 1, 2, 3, comma 1. There's the center. And the radius is 4. So 1, 2, 3, 4. Here's a point. 1, 2, 3, 4. Well, there's a point way up there someplace, isn't there? And 1, 2, 3, 4. Okay, so there's a point here. And really what I'm getting at is when we start drawing the circle, we're going to have something that does this, aren't we? If we go 4 down, that's going to be here. So it's going to come across and it's going to hit here, and then it's going to come up and it's got to pick up this other point. So it's going to come up. That's not a very pretty circle. But the point of it is that we have 2 x-intercepts and 2 y-intercepts, don't we? Okay, so how are we going to calculate intercepts? Well, in general, how do we do x-intercepts? Oh, we let y be 0 and we calculate x, don't we? So we take our equation, which is x minus 3 the quantity squared, plus y minus 1, but we're letting y be 0. So 0 minus 1 the quantity squared is equal to 16. And then, so we need to solve that for x. Well, let's look over here. X minus 3 the quantity squared. 0 minus 1 is negative 1, and when we square that, we get 1. So we have plus 1 is equal to 16. Now, what we could do here is we could now subtract that 1 from both sides, and so we'd have x minus 3 the quantity squared is 15. So a previous way of solving these called extracting square roots, if x minus 3 squared is 15, then x minus 3 itself could be positive or negative the square root of 15. And so we would end up with let's add 3 to both sides, so we'd solve for x. So we'd have x is 3 plus or minus the square root of 15. So the x-intercepts, okay, the x-intercepts, there would be 2 of them. One of them has an x value of 3 plus the square root of 15, but of course the y value is 0. And the other one has an x value of 3 subtract the square root of 15 and a y value of 0. So that's the x-intercepts. And we would find the y-intercepts in the same way. I think in the next problem I'll find the y, but next we would find y-intercepts. And we're not going to do it, okay? But how? How do we do that? Well, here we let x equal 0 and then find y. So we go through more or less the same process, except we're letting x be 0. Okay, now let's look at part B, which is to come up with the center and the radius of the second equation, which is x plus 2 the quantity squared plus y squared equal 1. And we'll do that on the next page. Okay, so what we want to know is the center of this circle, and we want to know the radius of this circle. And so we compare it with the standard form of the equation of a circle. Now, the first thing that we run into is that in the standard form of the equation of a circle, we have x subtract, not x plus. So what we have to do is we have to manufacture a subtraction. That is, we take our circle and we make it look in the standard way. And the standard way is x subtract. But if we have an x plus 2, what are we going to have to subtract? We're going to have to subtract a negative 2. See how x subtract a negative 2 is the same as x plus 2. So now our equation looks like x subtract. Now, we also need plus a y subtract, but we only have a y squared. Well, if we subtract a 0 from y, that's the same as y. And then we need to figure out what we have to square, because r squared is 1, what we have to square to get 1. Well, 1 and 1 squared are the same. So once we've written it in this form, then we can read the center. The center has an x value of negative 2 because that's the h, the value that's being subtracted from x. And the y value of the center is 0 because 0 is what's being subtracted from y. And of course then the radius in this case, is just 1. So we have the center and the radius. What about intercepts? Well, we could easily do that again. We could, if we were calculating a y-intercepts, or y-intercepts, and you know, it might be nice to know if there are any. Well, I kind of bungled that up, didn't I? Let's just real quickly kind of get an idea here. Let's see. If the center is at negative 2, 0, that'd be about right here, wouldn't it? And the radius is 1, then we're going to actually have a circle that looks about like that. And notice, there aren't any y-intercepts. Let's see what would happen if we tried to find the y-intercepts. See, there aren't any, are there? If we tried to find them, what would we do? We would let x be equal to 0, and we would have to calculate or find the y values, wouldn't we? Well, if we let x be equal to 0 in the equation, see, we'd have 0 plus 2, x is 0, squared, plus y squared is equal to 1. Now, when we do some calculations there, 0 plus 2 is just 2, and when we square that, we get 4. So this is 4 plus y squared is equal to 1. And we're trying to find y, so we would subtract 4 on both sides, and we'd get y squared is negative 3. And that's the problem, is because how can y squared be a negative number? How can y squared be a negative number? Y is a real number. And that would tell us that y has to be plus or minus the square root of negative 3, and that's a complex number. That doesn't make sense for plotting a point in the real plane, is it? So this would have told us no y-intercept. Now we can look above and see that we actually do have 2 x-intercepts, don't we? So if we were calculating the x-intercepts, okay, what would we do there? Well, we would let y be equal to 0, and we would calculate or find x. So in this case, we would have x plus 2 squared plus our y, which is 0 squared, we're letting y be 0 right there, is equal to 1. And so this would just end up being x plus 2 squared is equal to 1. And so x plus 2 is plus or minus the square root of 1. And of course the square root of 1 is just 1, isn't it? So we'd have x plus 2 is equal to plus or minus 1. So that gives us 2 different x values. X is, we'll subtract 2 on both sides, so negative 2 plus or minus 1. So the intercepts, and what is that? A negative 2 plus 1 is a negative 1, and a negative 2 minus 1 is a negative 3. So the x-intercepts as points, remember I told you that I consider everything intercepts as points. So one of them would have an x value of negative 1, and of course a y value of 0, and the other one would have an x value of negative 3 and a y value of 0, and that kind of matches our situation here. Remember, this is where 2 is, and so this is, negative 2, and this is negative 1, and this is negative 3. So that we could have figured that out probably a little more easily than the calculations, but I wanted to go through the calculations. Well, we'll finish out this section with calculating, dealing with the equation of a circle when it's not in this nice form. And so we'll do that next. As we prepare to finish out this section on circles, let me first make a point here, and this form of the equation of a circle, remember we call the standard form. The standard form of the equation of a circle. And this is convenient, of course. In this form, we can read the center. In this case, the center is 3, negative 2. That's a 2 right there. And the radius is 4. So this form is convenient because we can easily read the center and the radius from this form. But it's not always given in this form. And so let me go through this idea of expanding this equation. Expand. That means let's perform the squaring of x minus 3, let's perform the squaring of y plus 2, and let's rearrange the equation. So when we square x minus 3, we'll get x squared, and then you can verify this on your own. You'll get x squared minus 6x plus 9. So that's squaring x minus 3. And then we add to that squaring y plus 2. When we square y plus 2, we'll get y squared plus 4y plus 4. And of course, then we have equals 16. Now, what I want to do next is I want to rearrange these where I have the highest powers first and then the power 1. So I'm going to say x squared and then plus y squared. And then I'm going to put my x's in alphabet. I'm putting things in alphabetical order. So now I'm going to put my x to the first. That's minus 6x. And my y to the first. That's plus 4y. And then, of course, the 9 plus the 4 we can add together and get 13. And, of course, that's equal to 16. Now we're going to get 0 on the right side by subtracting 16 on both sides. So we'll have x squared plus y squared minus 6x plus 4y. And 13 minus 16 is negative 3 equals 0. Now, this is the same equation, just rearranged. And this is called the general form of the equation of the circle. The problem with this form is we can't look at it, and we have no way of looking at it and telling what the center of the circle is and what the radius of the circle is, although we know it's the equation of a circle because it came from the equation of a circle. Now, in terms that are more general, of course, we know that x minus h the quantity squared plus y minus k the quantity squared equal r squared is the standard form. And once again, it's useful because we can read the center right from the equation. It's h comma k, and we can read the radius right from the equation, and it's the value r. Okay. Now the general form looks more like this: x squared plus y squared plus some constant times x to the first plus some constant times y to the first plus some constant equals 0. And those constants a, b, and c might be positive or negative, and they could even be 0. Okay, but certainly that's the form. This is the general form. Now the deal is many times we're given the general form, and we want to know what the center and the radius of the circle is so that we can graph it. And so that requires us to rewrite the general form into the standard form. And the process of doing that, we have to use a technique called completing the square. And so that's what we're going to do next. Okay? We'll do that on the next page. Okay. Here our problem is that we're given the equation of a circle, and we know that it's a circle. We're told that. And the equation is in the general form: x squared plus y squared plus 4x minus 8y minus 44 equals 0. And we're asked to find the center and the radius of the circle. So recall, we need to have this written in the standard form. We need it to be written in this form so that we can read the center and the radius directly from the equation. Okay. So to do that, here's the process we go through. We take our equation and we rearrange it where we have all the x terms together. So I'll say x squared plus 4x. And then I'll say plus y squared minus 8y. And then the constant minus 44 I add to both sides. That is, I get it off the left side by adding 44 to both sides. So I have equal to 44. Now, I left some space in there, and so remember what we're really trying to accomplish. See, what we need here is a trinomial. That is, we need a number that goes with that x squared plus 4x so that when we have the right number in there, we can factor it so that it looks like an x minus h squared. See, that's what we're trying to do, and so we've got to figure out, well, what number do we need for our trinomial? And we're going to do the same thing for the y's. Y squared minus 8y plus some number, okay, we need so that we can have a y minus k. What that trinomial will factor as a y minus k squared. That is, we're trying to create trinomials that are called perfect square trinomials. Their factors are both the same. Now, of course, we're going to have to manufacture those new numbers to create the trinomials. And when we do, we'll have to add the same numbers also to the right side. So recall how we calculate this number that's called completing the square. we take the coefficient that is in front of the x and we divide it by 2 or take 1/2 of it. So 1/2 of 4, or 4 divided by 2, which is 2. And then we take that result and we square it, and we get a 4. So that tells us that we need a 4 in this position. Now, we just added a 4 to the left side that we didn't have before, so we have to simultaneously add that 4 to the right side. Now, for calculating this blank, we take the coefficient in front of y to the first power and take half of it, or divide it by 2. And that gives us a -4. And then we take that resulting -4 and we square it, and that gives us a 16. So that tells us we need a 16 in that spot. Well, we just added a 16 to the left side that we didn't have before, so we have to simultaneously add a 16 to the right-hand side. Now, I'm going to take this x squared plus 4x plus 4 now and factor it. So it's going to factor like this, I hope. And of course, that'll be an x times an x. And because we have a plus 4, this has got to be a plus and this has got to be a plus. And I think you can check out that if I have a 2 in both of those positions, I will have it factored. And so this is x plus 2 the quantity squared. And that's the kind of thing we're trying to create. Now, if I come over here and I look at the y squared that we created, the y squared minus 8y plus 16 that we created, we went to a lot of trouble to create this because now we need to factor it. And when we factor this, notice we'll need a y minus 4 times a y minus 4, and that will have it factored. And so that factors as y minus 4 squared. That is the kind of thing that we were trying to create. Now, I want to have you observe a shortcut, okay, and of this factoring. We can go through the factoring, but notice here we have a plus 2 inside those parentheses, and that plus 2 is because we had a positive 2 right there. And notice in here we had a -4 in this position when we factored. Well, that -4, that -4 is there, and it comes exactly from that piece right there. So I could have done this factoring more quickly if I would have recognized that. So anyway, here's where we are. I've done all of this work, but let's look at this equation that we've got up here, okay? And that's what we were trying to do, is to create this situation. So that x squared plus 4x plus 4 now can be replaced with x plus 2 squared, because that's how it factors. Plus, the y squared minus 8y plus 16 can be replaced with y minus 4, the quantity squared, because that's its factored form. And on the right side, we have 44 plus 4 plus 16, and you can calculate that and figure out that that's 64. So now that we have it in the standard form, say we went from general to standard, okay, now that we have it in the standard form, we can read the center. The center, the x value of the center is the number being subtracted from x. And so we'd have to say x subtract -2, since we have an x plus 2. So the center has an x value of -2, but a y value of +4, because 4 is what's being subtracted from y. And the radius is the number that we have to square to get 64, because remember, this side was representing r squared. And so the radius has to be 8 in this case. And we've determined, although we couldn't tell that from looking at the original general equation, we've determined now what the center and the radius is. And we could in fact graph this if we were asked to. Well, that concludes my discussion about circles. Good luck on your homework, and of course, as always, if you need some help, let me know.